Good afternoon, everyone. And it looks like folks are still joining. Welcome to this presentation on the 2021 Virginia Residential Energy Code and the changes in it compared to previous code iterations. My name is Andrew Grigsby. I'm Energy Services Director with Viridiant. Helping me today, whom you may see in the window there, is Stuart Knuckles. Who is our Director of Operations. And we are going to, I hope today, have a good conversation about the energy code and all things involved. We had quite a turnout for this, more than we were expected, and we're a little curious why it generated so much interest. This code change has, as you may know, it's been fully in effect since January, but of course there was the 12-month sort of warm-up period before that. And we presented on this several times in various venues. So we're excited to have all the interest and look forward to hearing from you about why there's so much interest. But we've got a bunch of slides to get through. I really want to hear from everyone in the room because there is so much expertise in this room today. And yet I want to try and get through this slide. So if you have questions or comments as we go, please put them in the chat or write them down so you don't forget them. We really want to capture that. And I'm going to get through the slides and then leave as much time at the end to have that discussion and take your questions. And I am happy to go 10, 15 minutes past time, but I want to make sure we get through the main content before the hour is up. So let's move on with this. A bit about Viridiant. We're a nonprofit organization. We were founded here in Richmond in 2006. And you might think of us as green building consultants. You might think of us as workforce training providers. We do a lot, but the bread and butter of what we do is certification for homes that are seeking one of the various above code certifications, Earthcraft, Energy Star, LEED, things like that. And since we were founded almost 20 years ago, we've certified more than 45,000 homes in Virginia and surrounding states. Our work is really based on building science, but then that sort of book learning is informed by work in the field and informed by energy modeling, where we do iteration upon iteration of changes to a building in the modeling software and learn and study about what every little detail can do to every different type of building. And we take that expertise and then look for ways to help the rest of the construction industry apply it. To me, it's just about building better housing that costs less to operate, that's more comfortable, that's more durable, that manages moisture, has better indoor air quality. So that's really what all this is about for us. This content has been developed really as a partnership with lots of y'all in the room, building code officials, some partners at DHCD, and grant funding that originally was funneled through SEIA, an organization down in Georgia, and originally it was Federal Department of Energy funding. So we appreciate that, and we're glad for that support so that we can do these sorts of trainings. So we're going to jump into an overview of what we've picked out as sort of the most notable energy code changes. And again, this is residential. We're in an hour's time. This is going to be quick, and we're just hitting the residential energy code changes. We're going to follow that with sort of a quick look at how the code overlaps a little bit with some of the incentives that are available for building more energy efficient homes. And again, we'll end up with your questions. But real quick, if you don't mind, we want to know well, we know who's in the room based on your registration, but I think it would be helpful for other folks in the room to know who is here. So if you wouldn't mind very quickly, scan that QR code, and we're going to have a couple more of these Menti polls as we go, just to get some quick information from the folks in the room. So if you wouldn't mind, you can scan that QR code or go to menti.com and use that that numerical code at the top. That's actually usually what I do, because I like using a keyboard rather than my thumbs, because my thumbs don't work that well. But this will give us a chance for everyone to really get an idea of who's here and who we're talking to. If you just joined, we're really just getting started by letting everyone else know who's in the room, who we're talking to. And so far, we've got lots of folks who work in local building code offices. And you know what I can tell you, looking at the registration list, it's a real range from building officials to plans reviewers. We've got, and some of whom specialize in mechanical or electrical, and a few field inspectors as well. Got some trades. I think that's primarily going to be installation trades.
Andrew, we're getting a couple of folks on the chat asking to repeat the option without the code if they're on their phones, or without the scanner if they're on their phones. Can you give or I can, it's menti.com, menti.com. And then you're going to use a code, which I'll put in the chat box, but it's 39675630.
Menti.com 39675630. All right, well, it looks like this is slowed down a bit. I'm going to move to the next slide here. And here the question is, which requirements in the energy code do you think are most important to quality, cost-effective home building? And this doesn't necessarily have to be the new energy code. It could be provisions that date back several editions, however far you like. But just to get an idea what you as code officials, as builders, developers, architects, etc., what do you think that's in the code is most important to quality construction? Oh, I don't see the okay, I didn't see the QR code, so I guess it's still the same one. I'm still learning how this Menti thing works. Okay, insulation's making a strong showing here. It's sort of the basics, what people think. Ooh. Okay, people calling out air sealing, mechanical system sizing. That's a good one. Window performance, leakage rates for, I guess, the whole home, and for duct leakage, air tightness. All right, these are great responses. Thank you. I'm going to move on here. All right, so jumping into the meat of the presentation. First, a slide I often start most anything related to home energy use. I'll start with a slide about, well, where does the energy go? And because to me, it's just sort of a grounding in what's relevant. And this is data from the U.S. Department of Energy's pretty exhaustive study in 2020, and it's for Virginia. Often I show a national average, and I'm happy to have Virginia data here. It's not very granular, as you can see. Other is a big bucket. And that will mostly be a big chunk of that is like appliances, plug loads. So many of the devices we're plugging in these days. But still, the biggest one is heating. That's where most of our energy goes. And if you add heating at 37% to air conditioning at 10%, heating and cooling count up for just under half of all the energy use in our homes. And in as much as the energy code speaks, I think, primarily to heating and cooling costs by way of air sealing, insulation, duct sealing, mechanical performance. This is really getting to at least half of folks' home energy bills. So this matters to people. This is what's important to us, because we think we're out there to really reduce the cost of housing, and we think energy efficiency is a real pathway to that. All right, so what's changed with the 2021 code? Well, to me, one of the big things is that Virginia is no longer all that 4A climate zone. We now have 3 climate zones, and we'll go through that. One of the issues related to that we've heard some talk about is the R60 attic insulation that's now required in zones 4A and 5A for some flat attic floors. Slab insulation, for years it's been 2 feet in length, and now it's 4 feet, and that to me is a significant change. There's a new requirement about maintaining loose fill attic insulation at the edges of walls inside attics. I've got a picture to explain where that shows up. The details on floor insulation, number 5 there. Nothing's fundamentally changed, but there's I think, some helpful specificity in the code about how to ensure performance. We've got more requirements for insulation and air sealing. I mean, it's all basic stuff, but there's a big table in the energy code that calls out where you must air seal, and that table continues to expand. Duct leakage, this is kind of big. All duct systems will have to be tested, and even those that are fully within conditioned space will have to be tested, and they can't leak more than 8%. Ducts outside of conditioned space remain at 4% maximum leakage. Number 8, mechanical ventilation. The whole home mechanical ventilation system, that is going to be you'll have to test it to see how much air actually moves through that system. We can't just put it in and assume it's moving enough air to provide the required amount of fresh air for the folks. So that's a change. 9 and 10 both speak to lighting and including sensors on both interior and exterior lighting. And finally, number 11 here it's a bit of an oddball. If you're following the prescriptive path and the requirements for performance pathways as well, but for most folks who use the prescriptive path, you have to do everything that's required, and then you have to do one more thing. You get to choose between these 5 here. So it's kind of a strange option in the code to my thinking, but we'll try and unpack it, and I'll be interested in your thoughts on it as well. All right, so that's a quick overview. Now we're going to talk about these in depth. Climate zones. So these climate zones, just so folks know, they come from ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and they track weather in every county in the country very closely because they are being relied upon by heating and cooling contractors to give them the right data for set points and for sizing equipment and for understanding the heating and cooling load of buildings. So they're just trying to produce accurate data about the weather that's actually happening. And so what we see is there is a lot more of the state that is now in that 3A zone that used to be just all below us in North Carolina. Really from Danville to Williamsburg and Virginia Beach, that whole southern tier there is going to be a warmer climate zone. And then up in the, let's see, that's Bath, Allegheny, and Highland counties, the three green ones in the inset there, and the cities of, I think, Covington and Clifton Forge. Those are the 5 jurisdictions that will now be this 5A cool, humid climate zone. And what that does is, if you're familiar with this table from the Energy Code, I mean, in your jurisdiction or for local officials, they'll, you can just look in one spot. For builders, architects, etc. You'll have to double check a little bit if you're building in a new place. If it's Norfolk versus Richmond, those are now 2 different climate zones. What we see as far as changes over here on the left side, that column, the window U factors, and again, U factor is just the mathematical inverse of R value, so it's thermal performance. Those go down to get greater thermal performance. It's still a double pane window that corresponds to around a little better than R3. So those are all a little better across the climate zones. And here's the one that people are talking about, that R60, which, as many folks know, in the 2024 model code has gone back down to 49. This tracks what's in the 2021 model code, the IECC, for these climate zones, and that changes again, but downward, which is unusual in the new edition, the 2024 edition of the model code. Walls stayed the same. They've stayed the same since 2012 here in Virginia. Meanwhile, the model code has, the model code went to R20 back in 2012, and now is at R30 for all these climate zones. Well, I'm not positive on that for climate zone 3, but that's something to keep your eye on for future code editions. Here's the slab R value, and then for those 5 jurisdictions up in the mountains, several more changes related to floor insulation and mass walls. So a bit on that R60. That applies when you're insulating a ceiling, when you have a probably vented attic, and you have your rafter or truss design such that there's not room for the full height of the insulation out to the outer edge of the top plate of the wall below. If that is the case, then R60 is what is required over the main field. There are a variety of ways to do that. Fiberglass, cellulose, but this is the current requirement. If you're using a raised heel truss, an energy truss that allows for, let's see, R49, around 12 inches height here at the outer edge of the top plate, then it's still R49 for zones 5A and 4A, and down in those 3A climate zone jurisdictions, it'll be R38. So again, it depends. We've got a lot of the state now that says 3A climate zone, big population centers in Hampton Roads, and all the way across the line with North Carolina over to Danville. So Just know where you're building. All right, slab insulation. So for years it's been 2 feet. The R value hasn't changed. It's still R10, which is often 2 inches of XPS foam, extruded polystyrene. This slide on the image on the right there, those are the examples straight out of the code book. I'm feeling they're a little dated now because it's rare outside of very far north that this height here is going to be 4 feet. We don't typically put our footings down 4 feet below grade here in Virginia. So there might be some version of this here on the lower left, and occasionally builders will use this bevel cut across the top, which is still allowed to hide the top of that insulation. Though in many cases, if there's between the drywall, baseboard, shoe mold, or carpet, much of that insulation is well covered. So this is kind of big. We had a in-person version of this training here in our office yesterday, and we allowed more time for that. So there was lots of discussion about this one too, as well as that R60. Just slab insulation in general, how the conditions when people don't want to do it, how much energy flows through solid concrete, and how much you want to insulate slabs as much as possible. But the nuts and bolts of providing that 4 feet in the field is going to be something that designers have to factor in, and then inspectors have to look for. Okay, here's that example of where there's this new sort of retaining wall requirement. And these are pictures trying to my mind, illustrate the problem. I took these photos in a house in Chesterfield County, Virginia, a few years ago. I was up in the attic, and it's a fairly complicated attic. There's this huge vault, but there's also these rooms upstairs. This is one of the bedrooms. And I was taking a picture of how the loose attic floor insulation really tapers off as it gets to the edge because it must, because there's nothing to keep it if it were the full height. Here's the view from up above, and this the picture on the right is looking up from the attic floor of the first, really the ceiling of the first floor, and looking at that same picture, or looking at that same area inside that vault there. So I'd always felt this was a problem because we really want that maximum insulation height covering the full perimeter of that conditioned space. Here's a diagram on the right, which I hope kind of captures the solution. And note, this is for loose fill insulation only. The idea being that we go back here, if this was batt insulation laid out onto the outer edge of the top plate, that theoretically that would provide good coverage. In my experience, those batts, if it's just laying there, it's easy to get moved, it's easy to get wrinkled and air get under it, and you get a real break in the thermal performance. But if you have loose fill, and if you have some sort of dam or retainer on the side that essentially runs like a sheathing layer for that insulated wall below, run it up high enough so that it creates an effective dam for that loose fill above. This can be a good design solution for folks. And throughout this slideshow, if you see text in quotes, that's taken straight from the code. So that is the actual code language there on the left. All right. I'm really missing the discussion here. I wish we could talk about this stuff, but I'm flying through the slides. Then we'll have time to talk about these. All right, floor insulation. As I read it, well, maybe things have. I'm sure there's people on this call who could tell me that the particular details that change, but I think the spirit of it hasn't changed much. But there are these 3 options detailed in the code. Option number 1 speaks to my mind, how most floors are insulated. And here we're talking about maybe the floor over a vented crawl space, the floor over a garage where you have finished space above a garage, or maybe the floor of some sort of cantilever or bump out. And here is the language from the code, which to my mind, in as much as it requires a permanent solution to keeping that insulation touching the floor above. And right here, and this is my opinion here, and the example shown illustrates what is my opinion, is that wire stays, I don't see how they're code compliant. This is a home in Chesterfield County that was it was about 14 months occupied. And already those wire stays were failing. And here it was an example of there was a lot of dampness in the crawl, making the insulation heavy. It was just poor craftsmanship putting those wire stays in, and a bunch of kids in the house who like to jump around. And, you know, the bats fall out. There's gaps, there's compression. I know it's the norm out there in the field, but I don't see how wire stays pass code. But again, that's Andrew's editorial right there. What I think are solutions that meet the code are something like spray foam here on the upper right, or to fill the cavity and have a more permanent solution holding that complete insulation in there. Could be netting, could be some sort of sheet good like Luan. It's more time and effort than putting up those wire stays, but to me, it passes muster with code. Again, we had a lot of discussion about this yesterday, but that basic language, permanent contact, in accordance with manufacturer instructions, that's not new. That's the way it's been. I'm just taking the opportunity to call out what I think is a defect in what is a very conventional application for floor insulation. So that was option 1. Option 2 allows an airspace, specifically allows an airspace, but in order to do so, you have to essentially make that cavity airtight. You have to have the proper the proper R value of the insulation that's below the R space and in contact with some sort of solid barrier below. And then the other key detail is that at the perimeter where those air cavities abut a band board, a rim joist, those joists will have to be sealed to make sure these cavities here will be airtight. If we're going to leave that airspace in there, we're going to make sure there's no air movement through it. And here, the entire required R value is cavity insulation there. Option 3 is where we either want to just have more R value, or we're achieving the R value with a combination of cavity and continuous insulation. So the only thing that's different here is that there is some thickness of foam board, or it could be rock wool sheathing that provides additional R value below the framing members. But again, those cavities must be airtight, sealed at the ends of the joists and along the sides, as is shown here. All right, moving on to air sealing. And here there's this table in 1102.4.1.1 in the VRC. a lot of it's pretty common sense stuff to my mind. And as a builder, you'll want to air seal as much as possible anyway, because you know you've got to pass the blower door test. I just called out a few things uh, in parentheses there. There's just a few new details that I were thought worth calling out. In particular, even as I read it, even with a vented crawl, one will have to air seal the butt joints of the rim board and seal the rim board to the sill plate. I think a lot of folks are very used to gluing down subfloors, so that sealant on top of the rim joist is not going to be new for most people. But then also sealing butt joints, such as shown here in this corner, between the rim joist members, and then also sealing the sill plate to the rim joist, that's probably going to be new. And in this drawing, they also show sealing the butt joint in the sill plates, which I didn't see as required in the code, but if you're there, you might as well. And what this does is makes that that cavity as reduces air movement through that layer of the building that is encompassed by those floor joists and rim joists. So there are lots of other, again, there's a lot of new text in that table that's called out both where and how and why you'll have to air seal. So it's worth taking a look at. Here's a slide which we had a lot of discussion about yesterday, and it made me dig deeper on it just this morning. And turns out it's not new text at all. I thought that was. I thought it was interesting, so I included it in the slideshow earlier. But that is the same text going back to the 2015 the Energy Conservation Code. We had a lot of conversation about this last fall at the VBCOA conference, where again, people seemed to, some folks in the room responded to it as I did, like it was new, but it is old. The main language here's the language from the code in parentheses. And what I take from that is you want to make the building substantially airtight at the sheathing layer. And to me, that's just good building science. We want to keep outside air out of those cavities that typically are insulated. So it's good building science. And indeed, unless you want to pay for the conversation at VBCOA annual convention last fall was about the cost of these air sealed electrical boxes, which are $6, $7, $8 a piece. No one wanted to put those in. So the solution is to do what's smart and make the envelope as airtight as possible at the sheathing layer. Variety of ways to do that. Tape, foaming or sealing on the inside. But again, this is not new. It goes back to the 2015 code. Moving on to duct leakage. And here, this is new. Any ductwork that's in conditioned space. Previously, if it was all in conditioned space, you didn't have to test the ductwork. Now you do, and it may not exceed 8% leakage. That's for folks who really in the weeds in this, that is total leakage, not leakage to outside. So 8% total leakage for ducts that are in conditioned space. For ductwork outside, stays the same, 4% is still the maximum. If you're not familiar with the duct test, it's a pretty simple thing. We seal off the duct system, we seal over all the registers, and then we pressurize the system and measure the excess air going through it. Doesn't take long. We get really critical data about the performance of the building. And a point to why this is so critical. These data are from the so-called field study that Veridiant participated in. We were the contractor for Virginia for this effort that took place across many southern states at the time and is extended to other states, where it was meant to be an investigation of not just what code is on the books, but how homes are actually showing up on the market. So we went out into homes that were, so at random, best we could, we went out across the Commonwealth to try to get to homes that were presumed code, meeting code and ready for occupancy. And what we found that even after that first incidence of Virginia requiring ducts to be tested. Now, prior to this, going back to the 2012 code, and I think even the 09, there was a maximum leakage rate for ducts that were outside of conditioned space, but we didn't require actual testing of them. We allowed the visual inspection to confirm leakage rate. Well, once we actually required a test and then went out to see how compliance was doing, results were pretty bad. We found that most homes, even when they were handed off to, presented as being ready and being code compliant, most of them were not. Some of them were failing, but 20, 30, the worst one we found was over 40% leakage. So duct leakage matters. On a hot July afternoon, if you go up into your attic, I was talking with a client the other day. He just bought a house, an older house, but he said he went in the attic and he felt cold air blowing out of his ductwork on a hot afternoon. And I said, yeah, it's an awful thing. You pay that; those are dollar bills you're blowing out of the ductwork. So this is ensuring low duct leakage is really one of the most cost-effective things we can provide to residents of homes. All right, moving on to a different kind of duct, the duct that is connected to your whole home ventilation system. And here's a slide showing the problem is that, or a version of the problem, is that when exhaust ducting is long and twisted and maybe stepped on or damaged or something else is sitting on it, it's real hard for air to move through it. And our mechanical ventilation systems, which have been required in Virginia homes since the 2015 code, they're required because we're building homes to be more airtight. And as we do to improve cost effectiveness and improve efficiency, we get to a threshold where we also have to have a mechanical ventilation system. And on balance, this is cost effective for residents. But we have to make sure that those ventilation systems are performing. We have to ensure that they are moving the amount of air that code stipulates. So that volume of air is unchanged. We're still using the same table that is based on bedrooms and square footage. And we're still using the same formula as an alternative to that table. So it's pretty easy to measure airflow. Here's 2 images showing one of our staff out in the field using that flow box and a manometer, calibrated flow box, and we can very quickly see how much air is moving through that fan when it's operating. And this is showing probably a bath fan and if it's running continuously or programmed for a certain time amount, we hope that that's the right amount of air for that home. Real quickly on ventilation, there are a variety of code compliant ways to meet the ventilation requirement. One is via exhaust fans that either, say the home, going back one slide here, say we have this home here where the table says 60, the formula says 50, maybe they opt for the lower number. You can use either one of these as you choose. So we have to move not fewer than 50 cubic feet per minute continuous exhaust from that home. So we can do it by having a fan that exhausts 50 CFMs continuously. And I think this image is real instructive because it shows in maybe in very basic ways, but it shows the fact that when you're taking air out of a house, air has to come in to replace that. The same amount. If 50 CFMs are going out, 50 CFMs are coming in. The question is, where do they find their way in? And most people, I think, as I deal with the general public, they seem to think, well, it's doors and windows, that's where it leaks. Well, here it's showing it comes through all kinds of cracks all over the building envelope. And that's just something to keep in mind. If we have a positive, so-called positive pressure system, where we're basically inflating the home, and then we're driving that air out through random leaks and cracks. And finally, we have balanced, where we are using fans to both bring air in and exhaust the same amount of air. So we're not intentionally driving outside air through the building envelope, or inside air to the exterior. This is preferred for lots of reasons, but the equipment to make it happen is more expensive. All right, we're up to number 9 here, 9 out of 11. A lot more dimmers and occupancy sensors are going to be required in all homes. There are some exceptions listed there, but a lot more rheostats coming your way. Similarly, on exterior lighting, if it's more than 30 watts, some sort of controller to ensure it's not going when it doesn't need to go. And so we can basically save folks a little bit on their electric bill. All right, last but not least, the additional energy efficiency requirement. So here I'm talking about the prescriptive path of compliance with the energy code. The next slide will cover the so-called performance pathways for the energy code, and they're different, but they relate to each other. And again, everything I've talked to thus far has been with that prescriptive path of where there are minimum R values, where we're not using a energy model to sort of calculate whole building energy efficiency. So for the prescriptive path, we've done all those things we've talked about. We've the R60 if necessary. We've tested the ductwork even in conditioned space. You do all that, then you have the option to choose among one of these other 5 measures to further increase the energy efficiency of the home. Now, I would encourage a builder, a designer, to plan ahead for this. Some of these, I mean, you could get to the end of your project and you totally forgot about it, and you can't change where the ducts are, you can't change the insulation. You could just throw in a more efficient heat pump. You could just throw in a more efficient water heater. Those are options. A great option, I think, is to just design this away by including all your ductwork in a conditioned space. Right there, you've met this requirement. You could include, in Virginia, if you use 2x6 walls, or included perhaps insulated sheathing above and the R15 bats in the walls, you could reduce your envelope average R value. That'd be a way to do that. Relying option number 4 here, just counting on achieving not more than 3 air changes per hour at the end of the process, that strikes me as a risky pathway, but it's an option to some folks. And if you're used to building a super airtight house and you know you can do it, then go for it. But again, choose from one of these 5 in addition to all the basics you've already met. That's how to apply this to the performance path, to the prescriptive pathway. If you're using the building performance path, you have to, and I'm frustrated with how this is worded. You have to score 5% better than your reference design, meaning they have set a standard and you're supposed to do 5% better than that. Kind of odd to me. Why didn't they just set the standard where they wanted it? But at any rate, this is how the text reads. But you still also have to then choose one of those measures we just went over on the previous slide, but you don't include that in your modeled proposed design. So you model the home as you model the home as you're not going to build it. You have to do better than the target that's listed, and then you have to do one more thing. Unnecessarily confusing in my mind, but I hope I explained that well enough. For the ERI, Energy Rating Index pathway, here all you have to do is perform 5% better than the listed target. You don't have to also then add in one of those additional efficiency measures. So clear as mud. Real quickly, and this is primarily for the architects and builders out there, and maybe the trades, there are some incentives out there here in Virginia, and in particular, if you're in Dominion's electric service territory, to build to the Energy Star standard, which is pretty achievable, as the next slide will show. You can get a meaningful amount of, about $4,000 to build Energy Star. Zero Energy Ready Home, that's a more stringent standard. And there, if you did that, you would also get the Energy Star. So if you're in this zone, you could get that 5,000 and the 1,450. So meaningful money designed to encourage builders to take that step up. And here's just a slide to show that so many of the requirements in our code right now really don't go beyond what's in Energy Star. All the testing, reviewing of the manuals J, S, and D, really the only thing that our code doesn't require, on this list anyway, is that energy model. But energy modeling could be a pathway to code compliance if you're using the building performance or the ERI pathway, the so-called performance pathways. So just something to keep in mind. If you're building a pretty good home, and even if you're already doing energy modeling, you might be closer than you think to meeting Energy Star. All right, real quick, one more slide here. Which new requirement among the ones we just went over, or maybe you have another one in your mind, you've already done a lot of homework on this. Which one do you think is going to be most difficult to ensure compliance with going forward? Be curious about your thoughts on that. And here we have I hope you can see the QR code. And if you go to menti.com, you can use code 39675630. All right, we're getting some variety out the gate here. Votes for ventilation. I can only see the top 10 here, so I'm not seeing what people are adding now. But this is very interesting. And I'm thinking of how it might relate to sort of who's in the room, code officials thinking about ventilation and thinking about what's actually out there. We've talked to a couple of builders about the R60 attic insulation and how, because of some of their particular designs, it's going to be a real headache. All right, very interesting. Thanks for sharing your thoughts. All right, quick recap here. New climate zones, R60 attic insulation, 4 feet of slab insulation, those retention walls or retention systems for loose fill attic insulation over some sort of vaulted room. We've got the specificity for floor insulation, and you got Andrew's editorial on that and the wire stays. Number 6, additional requirements for air sealing, which a lot of people indicated they think that's going to be a challenge. Now the blower door test requirement has not changed. We're still at 5 air changes per hour. So just FYI. Duct leakage, testing systems entirely within conditioned space, now not to exceed 8%. Confirming airflow in those mechanical ventilation systems. Yeah, I agree. They're going to have to be in operation. They're going to have to be present in operation and performing as designed. That may be one of those steps, may be a challenge, one or more may be a challenge in some cases. We've got our lighting requirements, and finally that additional measure that people have to do on the end. All right. If I said one more last time, I lied. Based on what we've seen here or sort of other issues on your mind, be real curious to hear what other topics do you, in this vein, energy related, performance related, what do you think you or folks in the trade need more opportunity to learn about? We're interested in that. We have a lot of materials we want to share. We want to encourage conversation around the state about this stuff, about duct testing, about ventilation systems, and the pros and cons of exhaust versus supply versus balance. So if you have some ideas, maybe it's something we just covered. Maybe it's ventilation. I think ventilation is one that we can learn more about. Okay, so the performance pathways, that's a good one. Using energy modeling to demonstrate code compliance, which is really, ComCheck and ResCheck. Those are performance, basically performance pathways, averaging out R values, etc. Let's see if I can move this. Communicating this to clients. I like that one. We talked a lot about that yesterday, and just sort of what people are willing to pay for. An important point is that the code sort of sets the floor. The code is the minimum. The code is what any new home buyer can reasonably expect their home to deliver to them. Whether they put a lot of thought into R values or SEER values or ventilation, this is the minimum. People are welcome to do more, but Virginia code says there shouldn't be less. So that's an interesting one. Certifications of individuals doing the duct testing. Now the code is very specific on that, but in my mind, it's a bit of an issue. And maybe it's something to address in the upcoming code change cycle, which apparently is going to be getting underway in June. All right, these are great ideas. Really appreciate you sharing that with us. As noted, we like talking about this. We like convening groups on this. We're going to send you this after the fact as well, or you can scan that QR code now, but you also get this survey via email. And again, we here at Veridient, we live and breathe this stuff, and we are available to help. All the kinds of folks on this call, whether from homeowners to code officials to designers, we do this testing. We do blower doors, duct leakage, and ventilation. We review manuals JS and D. We're doing a demo this evening here in Chesterfield County with Greater Richmond Professional Remodeling Organization. And we, as noted, like to do deep dives on some of these topics. So if you're interested in that kind of stuff, please reach out to us. We'd love to hear your ideas, and maybe we can bring something to your office. There's my contact information, and we will share these slides with you afterwards. And let's get to Q&A. We've got not many minutes left, but Stuart, can you share some of the questions?
Yeah, well, if you want to take a look at the questions there too, I was going to let people know if anybody wants to verbally ask your question, you can raise your hand down at the bottom bar. There's a little react button. You click it and click raise hand. I can come through and unmute you. Or there's a couple questions in here, Andrew, that we could answer as we're waiting for some of those hands to go up.
All right, I'm looking at the chat and I don't see.
Scroll up a little. Yep. There's one that I think was going back to the floor insulation from Jackie. Spray foam, shouldn't it cover the joists? But up around there, there's a few questions right there if you want to take a look.
I can't, I clicked on the chat and I don't see.
Okay. All right. I'll read them out. So Jackie was asking, and again, I think it's back on the floor insulation slides, potentially option 1. Looking at the foam isn't covering the joists, and shouldn't it cover the joists? Let me see if I got any here.
It's not required by code. That would be an example where it's just cavity insulation. Indeed, in the conventional method of putting bats up between the TJIs or the joist, you have that thermal bridging of the joist, but code does not require, when code says R19 in the floor, that is cavity only. It's a good idea to certainly to cover the joists and eliminate that thermal bridging. That's what this solution here would do, where you have that continuous insulation, but again, not required by code.
We just got a question. How about reflective insulation on walls and floors?
Reflective insulation. Oh, good topic. I'm going to go to an image of an attic here, which is where I'm used to seeing it, where the so-called radiant barriers you sometimes see. Radiant barriers are a great tool in the right climate. Where I mostly see radiant barriers are on this, up in the roof system, and they're designed to minimize radiant heat transfer through into the attic space and keep your attic cooler. It's a great tool. It's not appropriate for our climate. We're even climate 3. We're in a heating dominated climate. I met the guy who invented that. Peter Pfeiffer. He's an architect in Austin. He invented he stuck aluminum foil to a piece of plywood and said, hey, let's use this for decking and keep some of the heat out of our attics. And yeah, it makes sense in Austin, in Phoenix, in Jacksonville. But here in Virginia, think of a cold January day where it's 40 degrees but bright sunshine. We want our attics to warm up, because when that attic hits 80 degrees, you stop losing heat to it. And that's a good thing. And since you saw from the very first slide, we put way more energy into heating than we do cooling. So, yeah, reflective, where I see, and there might be other places you could put it. I don't see it there typically, but we're not in a climate zone where reflective barriers are appropriate in attics.
All right, we have a few more. Can you clarify what you mean by R13 plus 1? Are you counting wood sheathing and drywall?
So this is this table here. 13 refers to cavity insulation between the studs. And then the plus 1 is a layer of continuous insulation. It is, and here the drywall, the exterior sheathing layer, or I mean the structural sheathing or the siding, that doesn't count towards this plus 1. It must be an intentional just insulation layer. Now there could be there's structural insulated sheathing. There's a variety of sheathing products that have a layer of insulation built into them. But that +1 is meant to be the continuous layer of insulation. Sort of like, I mean, if this is an R5 and this is an R13, you'd call this 13 + 5, for example. If this is just R1, this would be 13 + 1. So that's what that means.
So Mike from Southbase asked that question and just raised his hand. So Mike, I'm gonna unmute or ask you to unmute yourself, and then you should be able to ask that question.
Thanks so much, and great presentation. That was really terrific. And yes, that clarified my question to an extent, that you're basically saying you have to do something slightly additive to an R13 assembly. Why only R1? And I like it because, and my other follow-up, and Andrew, you can answer both, is are most builders just doing the 15 in the cavity?
Yeah, Mike, thanks for joining. So
Pleasure.
this is an anomaly of Virginia. You're down in Atlanta area, right?
Yes.
Yeah, so this was our compromise in the 2012 code cycle, when the model code for our region went from R13 to R19 or R20.
R20, yeah.
And what we ended up with was these high density, the 15, which in my experience is what is mostly done. Those are the high density fiberglass bats that qualify as R15 in a 2x4 wall. That's what's often done, but you still have the option of, say, doing an R13 bat and putting on that 1/4-inch fan fold.
Fanfold, yeah. Yeah, that's
Somewhere in the
exactly.
assembly.
Yeah, and that's great. I was worried that maybe the +1 was gaming it somehow and trying to get credit for something. So it's additional to the sheathing and the drywall. So that's great.
Exactly.
Fantastic.
Yeah.
Thanks. That was a great presentation.
Thanks. Appreciate it.
Awesome. We got a couple questions from Wade. He's asking about the blown insulation dam. Is that something with the framer would install, or the insulator? And then he also asked, which was something that came up in our conversation yesterday, about the blower door testing, and if there's a small footprint testing stipulation there.
Oh, great question. So, well, as to which trade would do this, I mean, that's up to the builder. What this drawing shows here is what I think is an ideal solution, where you have some sort of rigid sheathing on the attic side. So here we have an unconditioned attic space, a conditioned room inside, and that sheathing layer has just been extended up to create a dam. Now, we see far too many, in my opinion, situations where, I mean, you go into older homes and you go in the attic and, here's what you see, and you see how this bat's falling out. There's looking at the edge of it. It's falling out, cold air falls in it. I mean, you can almost see the back. I hope you can see my cursor. You can almost see the drywall there. Well, if I was up there on a cold day, in that interior room shooting this wall with an infrared camera, it would be just as cold as the attic because there's no thermal protection there. The cold air falls right in. So job one is to provide the exterior air barrier for this cavity insulation. I mean, this home was built in the aughts, so it doesn't have it. And often I'll see Tyvek and they'll say that is, can be installed to be airtight. But Tyvek wouldn't provide a rigid barrier or dam up here. So to my mind, it's a strong argument for including a sealed airtight rigid air barrier to fully, it creates the dam up here. And then as a bonus, just keep running it down and fully encapsulate the cavity insulation for the wall below. But I mean, the basic of your question, who does this? Well, that's for the builder to figure out. And then the question on, I I guess it probably relates most to the duct leakage test. Is there some sort of leniency for homes that are smaller? The idea being 4%. This is 4% of conditioned floor area. And, most air handler, you might have the same size air handler in a home that's 2,500 square feet as a home that's 1,500 square feet. And so, yes, there'll be more length of duct work, but I mean, you get a lot of leakage just out of the air handler and the plenum, which might not be meaningfully changed between those two homes of very different sizes. And no, there is no leniency in the Virginia code. Now, the model code, if I'm talking to someone who works in other states, where a different, where they've created a different, where they use the model code or use a different version of their own code, state code, a different variation on the model code as applied to that state, it'll be different. The model code does allow for duct leakage a different number for smaller homes. I think it's 1,000 square feet. It might be 1,500. And on the blower door score, on the whole home air leakage, same thing in the model code. The 2021 and the 24 allow some leniency for smaller homes because that measurement is a function of size, and it's much harder to get a very small home down to that air changes per hour number. But in the Virginia code, no, one number across all home sizes. And folks, I know we've gone over time, but as noted, I'm glad to stick around and field your questions. But we will be following up with emails, sharing the slides, and that survey, and really appreciate your participation today. But we're going to roll on with questions. You're muted, Stuart.
There we go. Andrew, I just messaged you a couple, and then we've got somebody raising their hand. There's no name. It's 15403, but I'm going to unmute you to ask your question here. You should be ready to go.
Hi, this is Bruce Cornwall. As far as the insulation value of sheathing and stuff, unless it's been tested by the Federal Trade Commission under their standards and given an R value, then it doesn't have an R value. So it could have a U value, but it won't have an R value. So that sheathing and things like that can't be counted to have any value there.
Thank you, Bruce. Bruce knows more about all this than I do, so glad you're here, and thanks for chiming in.
You're welcome, Andrew.
Okay, Stuart, I still don't see what you've messaged me.
Okay.
I'm
Let's
sorry.
see. No, you're good. Okay, so now we're talking about air sealing requirements in a crawl. If it's a vented crawl, could the additional air sealing along the rim joist exacerbate any moisture problems?
Oh, great question. The answer is, if it's a vented crawl, would that exacerbate moisture problems? No, because that's the insulation layer. And that's where we want the insulation to be performing and not be compromised by air moving through it. We're not relying on that area as a place. We want to avoid that area being a place where moisture can either enter into the building or escape from the building. That opens up a whole can of worms about what the venting does and when it does different things, and the problems with vented crawl spaces in general. But no, this won't. You're not. And I guess the point being, are we relying on those cracks as an exit point for moisture from the crawl space? Well, no, and the reason is this. just like the intentional vents in your foundation wall, those are not magically one way. They don't only let moisture out, they let moisture in. Right now, I'm in Richmond, Virginia, and it's about 65 degrees outside, and it's been off and on rain. And in the crawl space, it's a little cooler, but it's not actually raining. But as this outside air enters that crawl space in with all its moisture and encounters a cooler area, the moisture in the air will condense and turn to water droplets. So it's just part of the problem with vented crawls in general. But no, to my thinking, this is not going to exacerbate any problem with moisture in crawl spaces.
Any requirements on pull down attic stairs?
Not new requirements that I noted. I could be wrong on that and just didn't pick it out to highlight. I know maybe Bruce can help me out. Uh, I know over the years we have varied a bit from the model code on what's exactly is required on attic access points. But I don't have a firm answer to your question as far as anything new being required there. I think I would have probably called that out if I did, but I don't recall anything new.
There's a question about the 2024 Zone 4 wall insulation, what Virginia is going to be, whether it's 20 and 5, 13 and 10, 0 and 20.
Yeah, well, if you have we don't know what it will be. The code update process is beginning now, as noted. We'll have months and months of debate over that. We'll have votes by the Board of Housing and Community Development. We shall see. If you know the answer to that, you've got a crystal ball. So yeah, it remains to be seen. I know there's a lot of people who are dead set against changing anything on that. So we don't know. It'll be up to the process. What I can tell you is that, again, the model code went well above this back in 2012, and it's been creeping up ever since, such that if I were building a new home in this climate zone and meeting the code minimum, I would probably be using 2x6 walls with cavity insulation with R5 sheathing. And that would be code compliant to the model code for climate zone 4A. But I might even put in more wall insulation because I think it's cost effective over the long term. But we don't know what's going to happen in Virginia over the coming months. But come join the conversation. It'll be a lively conversation, always is.
Don't see any other questions in the chat box. If anybody has any last burning questions, feel free to raise your hand or drop them in. But otherwise, I think we're wrapped up here.
Okay. Folks, we appreciate your time. We should have scheduled 2 hours for this because I'm sure if we had talked as we went through, there'd be a whole lot more conversation about some of these. But look for some email from us, and yeah, let's stay in touch about.
Just got one more, Andrew, too.
Go for it.
An alternative to sealed boxes.
So let's see that I believe that would refer to this slide here. So the way the code reads, and again, this is unchanged since the 2015 Virginia Residential Code, Virginia Energy Conservation Code. It means the air barrier shall be installed behind the box. And it means that your conventional box has lots of knockouts in it. And maybe some code officials on the call would say, well, would just caulking all the endpoint points on a conventional box, would that qualify? You then also have to seal the box to the adjacent drywall. I mean, as I read this, the air barrier behind the box, I mean, that's something like having the sheathing layer be, substantially airtight. So as shown here, this design where we're doing that sort of picture frame of sealing between all the studs and the sheathing, or maybe it was just caulked or glued when the sheathing was applied to the stud wall, or like that zip tape is pretty incredible stuff. I've seen it fail too, but again, these are not required unless you do not put your air barrier behind those. So hopefully that clarified. Feel free to follow up directly with it, with any of these questions. Love to talk through them. And again, I'm not the world's expert on this, but love to have conversations about this and bring in other experts as necessary.
Great. No more questions on my end.
Well, thanks, folks. Again, we appreciate your time, and we'll see you next time.